In this video, we're going to go through an application problem, finding an equation that relates y and x that's going to be logarithmic. So here, this table shows the mean distance x from the sun and the period y, or the time it takes the planet to orbit the sun, for each of the 6 planets that are closest to the sun. In the table, the mean distance is given in astronomical units, where the Earth's mean is defined as 1.0, and the period is given in years. Now the points in the table are plotted in our figure 4.18. So we're going to find an equation that relates y and x. So if we take a look at our equation here, well, not necessarily an equation, but at our figure, at our graph, it looks as though we might be dealing with a logarithmic type of equation. So our calculators don't really have something that's going to relate x and y together. So what we're going to do is we're going to transform this into a linear equation and then find the linear regression. And this is something that is done very often in mathematics and especially in statistics. So we're going to begin by saying that the natural log of y, or let's start with x. Because our x's are on top here. That the natural log of x is going to be represented by our capital X. And then we're going to let the natural log of y be represented by our capital Y. So we're going to convert this table that we have here into natural logs. So what we're going to do is we're going to take the natural log of 0.387. So we're going to plug that into our calculators. When we plug that into our calculator, we're going to get a negative 0.949. Then we're going to find the natural log of 0.241. So we plug that into our calculator, and that's going to give us an answer of negative 1.423. And we're going to do that for each of these pieces and each of these pieces. So I'm going to have you do that right now with your calculators. So go ahead and push pause on the video and do that and finish filling out your table, and when you're done, push play, and we'll go from there. Now that we have all those values, we're going to be entering those into our calculator. So go ahead and pull up your calculator and go to Stat, Edit, and here we're going to go ahead and enter in our list. So our capital X will be in our list 1 and our capital Y will be in list 2. So we'd have like negative 0.949 and negative 0.324 and so on. So I'm going to let you go ahead and do that. So go ahead and push pause and enter those values into your calculator for the X's and the Y's. And then when you're done, push play and we'll go from there. Okay, so now that we have all those entered in, we're going to go ahead and we're going to take a look at our stat plot here. So we're going to go into our stat plot and we're going to turn it on if it's not already on. Then we're going to go into our graph. So we'll hit graph. Oh, looks like I have some equations in there. So we'll clear out any equations that we might have. Hit graph, and looks like we need to adjust our window. So let's go ahead and let's make our window from 0 to 5, we'll count by ones, and then from 0 to 5, and we'll count by ones. We'll graph that. And it looks like we're missing out on some values because we did have some negatives. So we probably need to go from like negative 3 to 5 and negative 3 to 5. So let's graph that. That's better. So notice that we've converted all of those other points into a more linear pattern here by converting them using that natural log. So now we can calculate the linear regression and get our equation. So we're going to stat, calculate. We're going to choose option number 4, which is our linear regression. And that's going to give us a slope of 1.5 and a y-intercept of about 1.9. So we're going to go ahead and write that down. So now that we have that, we're able to write our equation, which is y equals 1.5. Remember that that y is not actually lowercase y. We were using a capital Y for that. So 1.5 times x plus our 1.99. So now we need to convert. Our capital Y really means the natural log of y, because the equation wasn't asking us for capital Y and capital X, but lowercase y and lowercase x. So we're going to place our capital Y with the natural log of y. and then equals 1.5 times the natural log of little x plus 1.99. Let's go back to our calculator really quick. We were pretty fast to put down our 1.99. If we take a look at that again, it says e to the negative 4 power, which actually means there's 3 zeros sitting in front of that. So really here, our b value is not 1.99, because if I had 1.99 and 3 zeros sitting in front of it, that would actually be a 0. So really, this should be a 0 here, which means that 1.99 does not exist. There we go. So that's kind of cleaned up there. So we'll go back. We'll just double check one more time on our calculator, our values. And now we're going to go ahead and plug that into our y equals. So y equals, well, it's actually kind of hard to graph that because it's the natural log of y, not y. So if we wanted to graph this to check it, we would need to get rid of that natural log there. We're going to save that for a different lesson. But I can tell you that it does in fact work. And this becomes the relationship that we're looking for this particular equation. And that this will fit our line with 99% accuracy. Now, if you are wanting to see that, we can go ahead and do that now. But if you haven't talked about solving for y using natural logs, this might be a little bit much for you. And so you don't have to do this, but it's what you would do. So if we had the natural log, the natural log of y equals 1.5 times the natural log of x, and we were trying to get the y by itself, so we could in fact graph that and see it. Remember that the natural log is technically just a log base e of y. So to cancel this out, what we would do is we would take e, right, our base, because it's all about that base, Come over here to the window, which is our 1.5 times the natural log of x, and then head on back to the wall, right? So that's going to equal y. And at this point, we're able to graph that. So if we pulled up our calculator again, and this time we put in that equation, so we put in e raised to the 1.5 times the natural log of x and graphed that, we would see that it would fit our original data, okay? So again, we're not really looking for that to fit our linear line. If we were checking our linear line, the equation that we would plug in would be our capital Y and our capital X. So if we were to check that one, we can do this in red. We put 1.5x. When we graph that, we see that it matches through that data perfect. So by reconverting it back to the natural log, it matches our blue line, which matches our original data set. But you could check it simply by plugging in your y equals 1.5x and seeing how it relates linearly as well. You don't necessarily have to go through this whole process to do that.